Math with Mr. Williams, Example 1. Using models to simplify expressions. Use the models to simplify the expressions. Explain your reasoning. Okay, so first off, anything like this, let's focus on the area formula, which is area equals length times width, and we're going to apply this to this factored form. All right, now we have to use this model. So here we see that this is 3 times x plus 4, and here is 3 times x plus 4. So we can call this the length if we need to. This can be our width, and we're breaking that up. So here we have 3 times the first term, which is x, and that's broken up into this box. And we're going to add that to this box that represents the 4. So in the first one, if we follow the area model, it'll be length times width. So we'll call this one the length then, and this the length for this box. So this would be 3 times x, or just 3x. And on this one, this would be 3 times the 4, which would give us 12. So now we bring those back together. So we have 3x plus that 12 would be our expanded form. We can also show this with distributive property. So we have 3 on the outside, x plus 4, and we're going to multiply the outside term to both the inside terms. So 3 times x would give me 3x, and 3 times 4 would be 12, and then we would just bring down our addition symbol, giving us the same exact expanded form answer. Math with Mr. Williams, Example 2, Simplifying Algebraic Expressions. Use the distributive property to simplify each expression. So here's the first one. We have 4 times the parentheses of n plus 5 in parentheses. So we're going to draw our arrows here. We know that 4 is being multiplied to the n and the 5. So then we have 4 times n plus 4 times 5. 4n is just 4n plus 4 times 5 will give me 20 as my answer. For the second one, we have the 9 being multiplied to everything in the inside. So I'm going to draw my arrows, 9 times 6, 9 times the x, and 9 times the 2. We write it out. And now we're going to go ahead and multiply it out. So 9 times 6 will give me 54, plus 9 times x will be 9x, plus 9 times 2 is 18. Now we're going to use our commutative property and bring our numbers that are alike next to each other. So we're going to move the 18 closer to the 54. 54 then plus 18 plus 9x. And we're going to combine these like terms. 54 and 18 will get us 72. Bring down the plus 9x, and we have our answer, 72 plus 9x. Math with Mr. Williams, Example 3, Finding Dimensions. The models show the area in square units of each part of the rectangle. Use the models to find missing values that complete the expressions. All right, so here we have 8 plus 24. That's considered our expanded form, and they want us to factor it using our model. So we have an 8 and 24, so the first thing we need to do is look for our greatest common factor. I know 8 will go into 24, so if I bring an 8 outside, then 8 times what is 8? 1. 8 times what is 24? 3. So now I have it factored. So when I bring it back over, I know my 8 is going to be factored out of the 8 and 24, and what's left inside would be what I have for my remaining side lengths. So 1 plus 3. All right, for the next one, we have 3x plus 18. Let's just go ahead and show it as a factor tree here. So we have a 3. It can be factored into 1 times 3. And then 18, since I know there's only a 1 and 3 on this one, we got to check for the 3. It can be broken into 3 times 6 for it. We don't need to complete the tree anymore for the 18, so what we have here is the common factor or multiplier in it is 3. So I'm going to factor out my 3 in the outside. So what times 3 would give me a 3 times x? Well, that would just be x. And what times 3 would give me 18? That is a 6. So then I have my factored form. We factored out the 3, and we're leaving in an x plus 6. Now we can check each one of these just by multiplying using our distributive property. We can draw our arrows on the top one. 8 times 1 and 8 times 3 would give us back to 8 plus 8 times 3 would be 24. And to check the bottom one, 3 times x and 3 times 6. 3 times x is 3x, plus 3 times 6 would give us 18. So we checked each one. Math of Mr. Williams, example 4, factoring algebraic expressions. Factor 3x plus 42 using greatest common factor. Okay, so let's go ahead and break this apart. I like to start with my smaller number here. So we're going to start with the 3. What times what gives me 3? Well, 1 times 3. Okay, those are prime numbers, so I leave it alone. But the 42, let's break him up. What times what gives me 42? Well, how about 6 times 7? 7 is a prime number, so I leave him alone. The 6, though, can be broken up into 2 times 3. So I just bring down the 7, and it's times 7 at the end. And here are my factored form of the 42. So what do they have in common? They have the 3 in common. So then what's remaining would be a 1 on the first one, and a 2 times 7 would be 14. So the math would be 1 times 3 and 3 times 14 on the second one. So let's go ahead and factor that out. So to write it, we're going to divide out the 3 and pull it out front. So now he's out front, and what's remaining inside would be 3 times what gives me x. That would be x. 3 times what gives me 42. That was our 14. And so there's the first one. All right, the second one, we have a 63 and a 27. I like to start with the smaller numbers, so let's go ahead and break up the 27. And that gives me 3 times 9. Let's go ahead and break up the 9 since the 3 is a prime number. That would give me 3 times 3. So my factor form would be 3 times 3 times 3. Those are all my factors for 27. All right, let's break up the 63 now. All right, what times what gives me 63? Well, how about 7 times 9? And 7 is a prime number, so we're going to now break up the 9. So that gives me 3 times 3. So if I bring down the 7, it'd be 7 times 3 times 3, and box that in. What do they have in common? They both have 2 3's in it. So 3 times 3 would be 9. So I bring the other 3 down. So 3 times 9 would be 27. And on this one, 3 times 3 is 9. And I bring down the 7. So now my greatest common factor in this one would be 9. So I'm going to bring him out front with my parentheses. And what times 9 gave me the 63? That was the 7. And then I cannot factor out any of the variables. So z stays, minus what times 9 gave me 27? That was 3. And so I bring the y back in too. All right, and there's our second answer.